Example 2-3 is about a trapezoidal channel with the bottom width of B01 equal to 4 meters and sidewall slope of 1 vertical for 2 horizontal. So M in this case is equal to 2. And it experienced a bed level raise by 0.3 meters. So delta Z in this example is 0.3 meter. The channel carries a discharge of Q equal to 12 cubic meter per second, and water level is Y1 is equal to 2.1 meter. Assuming negligible energy loss, calculate water depth after the raise. So we need to use energy equation. So using energy equation. So we have a trapezoidal cross section, so we cannot use y1 plus v1 squared divided by 2g as a total energy unless we calculate y1 based on trapezoidal cross section. So the energy in section 1 and section 2 can be y2 plus v2 squared divided by 2g. So you can still use this energy equation in this form if you properly calculate velocity. So using continuity equation, V1 is equal to Q divided by A1. And we know that in trapezoidal cross section, A1 is equal to B0 plus My times Y. So we have the bottom width and sidewall slope and depth. So in that case, we can calculate area. So B1 is equal to 4 meter. So 4 meter plus 2 times 2.1 times 2.1 gives me 17.22 square meter. And now I can use continuity equation to calculate velocity, which is Q divided by A1. And here I have 12 divided by 17.22. So it gives me a velocity of 0.6968 meter per second, or I can simply say that it's 0.7 meter per second. So now I can calculate energy at section 1. So E1 is equal to Y1 plus V1 squared divided by 2G, which is equal to 2.1 plus 0.7 squared divided by 2 times 9.81. And that gives me 2.1247 meter. So if you compare the depth and energy, you will see that it's very close to the depth, means that the contribution of kinetic energy in this example is very small in comparison with the depth. So we might not see a huge water level drop in this example. So now if I want to write energy equation at section 2, so we have E1 is equal to E2 plus delta Z. So therefore, E2 becomes equal to E1 minus delta Z, which is 2.1247 minus 0.3 is equal to 1.8247, 1.82475 meter. So it is always required to keep at least 3 digits after the decimal point for exam or proper carrying over the information. But nowadays, if you solve these problems in Excel, you can just keep all the digits after decimal points. That provides the most accurate answer that you have. So now you need to write the energy equation in complete form. And the best idea is to use try and error. So you can just use Excel and develop the energy equation. So I have E2, which is equal to Y2 plus Q squared divided by 2G A2 squared. So if I want to calculate A2, so A2 is equal to B2, or I would say that it's B02 plus MY2 times Y2. So if you look at the sketch here, so we have B01, which is equal to 4 meters. And then we have sidewall angle or sidewall slope of 1 horizontal, 1 vertical to 2 horizontal. So delta Z is 0.3 meter. It means that within that 0.3 meter raise, you're going to have 0.6 meter increase on the width. So you have 0.6 meter from one side, from the left side, and then 0.6 meter from the right side. And that gives you B2 or B02 is equal to B01 plus 2 delta Z M, which is 4 plus 2 times 0.3 times 2. Okay, so that gives me 5.2 meter. Okay, so this value is known, 5.2 meter, M is known. So the only unknown is Y2. G is known and Q is known. So you need to do try and error. And then if you do the try and error, or what I can write here, I can write that 1.82475 is equal to Y2 plus 12 to the power of 2 divided by 2 times 9.81 times 5.2 plus 2 times Y2 times Y2 and everything to the power of 2. So you'll see that we have one equation, one unknown. You can develop the right-hand side into Excel file and then keep Y2 as an unknown cell. And then you can do the try and error. The best first trial is try the exact depth. So if we look at the sketch here, so if Y1 in example is 2.1 meter, and then we have 0.3 meter. So without any change, Y2 should be 1.8 meter. So 1.8 plus 0.3 gives you 2.1 meter. So if you try 1.8, then it will give you a value for E2. And then if you adjust, so try Y2 equal to 1.8 meter. And then you can adjust that to get the actual value. So the answer will be Y2 is equal to 1.795 meter. Okay, so you'll see that as a result, the water level drops by 5 millimeter. Okay, so if we don't have any change in water surface, the answer is 1.8 meter, but because of the change on the energy level, then the water level drops by 5 millimeter.